I was just trying to see if you could hear anybody else.
Can you hear me?
I can hear you. That's all that really matters, to be totally honest. We'll figure everything out in a second. But you can hear me, right, Franco?
Yes.
Okay. Um, I was trying to find like a quick animation for you so you could see what we're talking about.
I
No.
found them. I sent them to you. I posted one in the jumbotron, but I wasn't sure if you were seeing an actual interferometer, like the lights, or if you wanted something different.
Oh, okay, yeah. Okay, Franco. So this may help. This may be good enough. Thank you, bro. This may help. So Franco, I'm gonna send you like a quick visual so you can see, and maybe this will help get some more solid answers out of you. Probably not, but like if you could dumb it down for Flat Earth Fridays for us, so we can get through some of these questions, I could appreciate that. So if you can't check your DM from me, try not to do too much. Cern, chill off, Franco. Let him get a few keystrokes in, and see if you can see that animation from Lunar Heritage.
I'm watching it. Yeah.
Okay, so you see like the light beams. Are you familiar with the setup?
Yes. Yes, I
Okay,
am.
so let me just ask you, and hopefully this helps, and we can get past. If that frame was rotating, would one of the light beams travel a different distance than the other?
I don't. First impression is no, it wouldn't. But if it's rotating around an axis which is perpendicular to the plane from the two beams, uh, I think there should be no difference.
Thank you. So we could say that it will detect a rotation because it will cause an interference. Based
No,
off
it
of the
depends
frame.
on the direction of the angular velocity. If
Okay,
probably if
assuming it's spinning in the right direction.
no, if it's my impression, I would have to make calculations and confirm this. But in my impression is that if the rotation axis is perpendicular to the plane of the two beams, then you will measure nothing. Whereas, if for instance, if the rotation axis is along one of the beams, then then of course the one of the two mirrors will not move. The one on the axis, the other one will move, and so the path traveled will be different, will be longer for the rotating. Basically, one of the two mirrors will be rotating and the other will not. If the rotation axis is along, for instance, the horizontal beam in this animation, the other one will move and the first one will not, and so you'll see a difference. This is my first impression, but I'll have to confirm this with. So it depends. My answer is that it will depend on the direction of the rotation.
Okay, hold on.
These are experiments that have been done, though, right?
Yeah. Still to this day, and
Right.
interferometry only has gotten more sensitive.
Yeah. So if he can just acknowledge that this has been done, like he doesn't need to worry about all the stuff he's worrying about. It's been done correctly multiple times.
All right, give me 2 seconds, Franco. I'm just trying to verify this paper real quick, so we can kind of, because I know you're not gonna really appeal to any of these questions unless I cite something. Then you feel more comfortable.
No, and unless I understand what it's talking about, and unless I've thought about it or see calculations.
Okay.
If I cannot answer you, I will tell you.
He wants some calculations, dog.
I know you want to calculations. I feel that though.
That's what physics is about, calculation, you know.
No, it's not. Physics is about the
Okay.
mechanics, bro. We went over this already. Physics is about the mechanics. You use calculations to describe the mechanics of your physical world. We went over this, bro. You know I'm right. You know I'm right. You know I'm right. Okay, hold on. I'm downloading this. Trying to see if I can
No,
look it up.
thank you for this defining a physicist to a physicist. Thank you.
Stop appealing to credentials. Stop
No, it's not
appealing.
credential. It's a fucking definition of physics.
All right, Franco. Okay, relax.
Yeah, you can laugh at every time you want.
Bro, I'm just saying, you know that there's a difference between describing something and explaining something. Like, obviously, we want the math to explain certain things, right? I mean, to describe certain things, but we're talking about explaining it.
Physics is a quantitative science. You need to make quantitative statements.
I low key kind of agree with that. This is taking too long, bro. I can't validate this fast enough. Okay, this might be it. Hold on. Uh, okay. Let me see. Maybe this will suffice. So this is optical interferometry in astronomy. We see telescopes instead of slits and a beam combiner instead of a screen for a viewing fringe. In a real interferometer, we must use delay lines to compensate for geometrical delay introduced by sidereal motion of stars across the sky. Now, I didn't read this whole thing, so I'm looking it up in real time. But from what I just read to you, does this describe a circular motion that's affecting the interferometer?
I think it.
Stop.
Yeah, it might be. I'm not. I'm not sure. I got it, but I think it might be. Is it an interferometer on Earth, or is it an interferometer or the satellites or something like that?
It doesn't say anything about a satellite, Not in this.
It's on Earth. So if it's on Earth, probably the sidereal means, the rotation of Earth with respect to the stars and not with respect to the sun. Yeah.
Okay, and an ether isn't required for this detected circular motion, right?
No, no.
Okay. Now we're probably gonna disagree on whether circular motion is the same as angular motion. But I'm just gonna chalk it up as it is the same thing because I mean we've already validated that it works like that. But let me just move to the rest of these questions. But hopefully we can find a little bit of common ground there. And now I'm glitching. I cannot believe this, bro. Like we lost the flow of the questions trying to get through this. But
I also can't hear Franco, by the way.
all right, you got to drop down and then come back up. But like, I don't know. Like, sorry, bro. Just don't do anything. Matter of fact, it's all good. Go ahead, drop down and come back up. Oh my God, there he go. I'm about to give up, bro. Like I'm about to give up. Go ahead, Proud. Drop down and come back up.